My name is Madison Waldie.
My name is Meredith Harkema.
And this past year we did independent research efforts here at SAU, and then over the summer we took those efforts to Montreal, Canada in the ASPB conference.
So what we're looking at is the effects of ginkgo tides, which are short polypeptides from ginkgo biloba plants, and how they affected fungal growth as well as bacterial biofilm formation. Previous studies have shown that those ginkgo tides affect fungal formation. However, there are very few studies showing how they affected bacterial biofilm formation.
So we extracted our own ginkgo tides, and this was based on the published literature. So to start this, we collected our own leaves from our own ginkgo tree outside of Whiteman Gibbs. These leaves were then dried, crushed, and the resulting powder was incubated in sodium acetate glacial acetic acid buffer solution. We took this homogenate and passed it through cheesecloth, and then the filtrate was centrifuged, and then we stored the supernate at 4 degrees Celsius and at -80 to help keep the proteins from degrading. So I specifically studied the effects of ginkgo tides on fungal growth and development. And we ran a few different assays. The first one that we ran, took potato dextrose agar plates, streaked the entire plate with Fusarium oxysporum, which is a common tomato pathogen. And then we divided the plate up into 6 different areas and applied ginkgo tide treatments of varying percentages and put those on filter paper and tested to see what growth would happen. We got some mixed results. We were worried about uneven streaking, so we decided to try a different type of assay. And this was a full plate assay. Each individual plate was streaked, and then the plate was streaked again with the different treatments. We also had controls of sterile double distilled water and glacial acetic acid at pH 4. And this was just to test if the pH level of the ginkgo tide solution was killing anything. And so we let these plates grow, and we found that we had growth on the water plate, but not on any of the ginkgo tide treatment plates. Lastly, we've tried an assay that was published in literature, and we wanted to see what this one looked like. So we grew up our own fungal cultures, and then took a little bit of that and placed it in a new plate, and we placed treatment on filter papers and decided to see what growth would happen. And you can see here that this was the original spot of fungus, and it has grown out, and it has grown towards the sterile water and the glacial acetic acid, but it has this crescent shape here that was observed in the literature as well, and it's the delayed growth of fungal hyphae. And this, like I said, was shown in the literature, so this matched what they found. And lastly, we checked spore viability. So we took Fusarium oxysporum, placed it in potato dextrose broth, and then let it incubate, put it on microplates. The developing hyphae were killed off with methanol, and then we exposed it to methylene blue dye to see how much dye was captured. And this graph here, you can see that the higher the percentage of ginkgo tide extract, the less methylene blue that was captured. And that shows that fewer spores were being made, or fewer spores were viable.
I used that same ginkgo tide extract to test how it affected bacterial biofilm formation. So we used Bactotrypto broth media and flocculent bacteria in every single column of our microplate, and then we added various amounts of the ginkgo tide solution to each column, and then we used, as a positive control, 20 millimolar sodium salicylate, which at that level has been shown to inhibit bacterial biofilm formation. And then as a negative control, we used sterile water, and then the plates were then stored and incubated to encourage that biofilm formation. After they incubated, then we washed the wells with sterile water again, put crystal violet in there to stain them, and washed it with water again. Then we let the plates dry, then resolubilized the crystal violet using glacial acetic acid, let that sit for 15 minutes, and then transferred that into a new microplate, which was then put into the reader. So this is the qualitative data showing different amounts of bacterial biofilm formation. So with the ginkgo tide extract, you can see that there's very little to no growth as seen by the light colors, because the crystal violet would stain any bacterial biofilm that is in there, which is why you get a darker color with the 0% ginkgo tide extract. And then even with the 20 millimolar sodium salicylate, which again we know to inhibit bacterial biofilm formation, you do still see some coloration, which shows that the ginkgo tide extract is probably even better at inhibiting that biofilm formation than the sodium salicylate. This is just some quantitative data of the same information. Again, low levels of growth are seen with the ginkgo tide solution, and then higher levels with water or the sodium salicylate. And then the absorbance values come in because the crystal violet would then is whatever is stained of the bacterial biofilm, that's going to increase the absorbance levels, so that you can see that with low levels of bacterial biofilm, it's a lower level of absorbance. These are our references here. We would like to thank the ASPB for granting Maddie a travel grant, as well as the Natural Science Department here at Spring Arbor University for all that they do to encourage student research and travel efforts to present at conferences.